one of the topics we cover is probability. Probability, another word for that, chances. What are the chances of this occurring? An example would be if I had a coin. Okay, and we've watched, there's other videos you can watch that I've done on this. But a coin has two sides. In some currencies or some countries, they'll have a heads and a tails. In UAE, we have the one, and on the other side, we have the dala, the coffee pot. So will it land on the one, or will it land on the coffee pot? Other countries, heads or tails. So you have 50% chance of it landing on heads, and a 50% chance of it landing on tails, or half and half. Now, if I flipped the coin and it landed on heads the first time, the next time I flip it, are the odds different? Has it changed? Or will it still be a 50% chance of landing on heads? Yes, it would. It still has a 50% chance. I could flip the coin 9 times, and even if it's landed on heads every single time, the 10th time I flipped it, it still would have the same chance as what it had every single time, a 50% chance. Nothing else has changed. It will still have a 50% chance of landing on heads and a 50% chance of landing on tails. So theoretically, it's like a theory was put in place based on sort of ideas. It should, if I flip it 10 times, it should theoretically land 5 times on heads and 5 times on tails. But the other word that we tend to use with probability is experimental. Like an experiment. When you do science, you do an experiment. You hypothesize what will happen using your clues. I hypothesize that this will happen because I know blah, blah, blah. Experimental probability is when you actually test the theory. So theoretically, if I flip the coin 100 times, theoretically, it should land 50 times on heads and 50 times on tails. But when I actually do the experiment of flipping it 100 times, it does not always come out like that. In fact, it's rare that it does. But if I flipped it 100 times, it might come out at 65 heads, 35 tails. The more times I do it, so if I did this 100,000 times, it would become more closer to 50% heads and 50% tails. So theoretically, it should balance itself out. It won't always be equal, but the more times you do it, it could happen. Same with the dice. 6 sides on this one. If I rolled this 1 time, theoretically, I have 1 chance out of 6 of it landing on a 4. If I rolled it 6 times, theoretically, it should land on a 1 at some stage, a 2, a 3, a 4, and a 5, and a 6. But if I did the experiment and rolled it 6 times, it might land on 4 2 times. It might land on 1 time, and it might land on 6 3 times. But the more I do it, the probability is more realistic and more aligned with the theory. So here I have some cards to show you what I'm talking about. Cards have what is known as suits, which is we have a spades, we have a club, which are the black colours, and then we have the red colours, which are hearts and diamonds. So a suit is where you have what is known as an ace, a king, a queen, a jack. Then we have numbers of 2, 3, 4, 5, 6, 7, 8, 9, and 10. Each suit has 13 cards. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So the jack is pretty much, say, 11 points. Queen is 12 points, king, 13 points, and the ace is 1 point. Now there's 13 in each suit. There's 4 suits. 4 times 13 would give you, and I know a smart person might know the 12 times table and say, well, 4 times 12 is 48. If I add 4 more, would give me 52. So what is known as a deck D-E-C-K, deck of cards, has 52 cards, 4 different suits. However, you will find that some cards have 2 jokers as well. So you would actually then have 54 cards in a deck. But for this purpose, I'm taking out these 2 jokers. And in this case, I'm just going to be using the spades. So the spades, which is the black one, in this game is predicting higher or lower than that last card. And in this case, I can see, this is where your maths comes into play. And it's good to learn maths in a fun way. So here, I can see a jack is here. Here is the jack. It's worth 11. Now I can see anything higher than a jack is the queen and king. So if I've turned over 1 card out of the 13, there are 12 left, 12 cards. So at the moment, of Mr. Blair turning over a queen or a king, I have 2 chances out of 12. 2 chances out of 12. To turn something over that's lower than a jack, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 chances of it out of 12. If I simplify these fractions, it's the same as saying 1/6, or here 5/6. So clearly, the favourite one would be lower than jack. Theoretically, I should get one of these. But anything's possible. It's not certain that I'll get a lower card, but it's highly likely. It's got a greater chance than me turning over queen or king. So I'm going to pick higher. I'm not sure if you can quite see this. Down here it's got higher or lower. So let's try this. I'm going to go with lower. It has to be lower, surely. Lower, yep, I'm going to lower. What is the probability of the card? Well, I know, we've done our calculations, 2 out of 12. I've simplified it, so it's 1 out of 6. What is the probability next card turn over than the previous card? Well, it's 5 out of 6, so I'm not sure if I write this. Maybe I'll just write 10. Let's find out. No, I've got it down here. Sorry, Mr. Blair's didn't see the lower one. I'm putting 5 out of 6. 5 out of 6, check again. And they're saying, how much are you willing to risk? And I'm going to say, I've got £10. I'm going to go with 9. I think it's going to be, yeah, let's go with that. Play. And it is a 7. Now 7's a tricky one now, because 7's sort of in the middle. So the jack's gone, 7's gone. Is it going to be higher or lower? So at the moment I've got 6 left that are lower than 7 out of 11. And I've got an 8, 9, 10, 3, 4, 5 out of 11 that will be higher. So again, it's very even, but I'm leaning, obviously, based on these facts, it will be lower again. It's almost a 50% chance. Not exactly 50, but I'm going to go with lower again, based on these calculations. So make it lower, it's saying 6 out of 11, because I've only got 11 cards left, don't I? Let's have a look. I've got 19 on. Not so sure. I'm just going to go 5. Let's see. It is lower. Yes. Now, so the 6 is gone. This now, I've got 5 chances out of 10 of it being lower than 6. Ace, 2, 3, 4, 5. It's been higher. 8, 9, 10, queen, king. The odds are even, which means it's a 50% chance that it's going to be lower and a 50% chance it's going to be higher. Not great odds. It's even chance. So in which case, I'm thinking I'm going to go higher this time. We know it's going to be 5 out of 10. So if I put 5 out of 10, which is the same as saying 1 out of 2. Let's see what if they let me do this one. 5 out of 10. Yep. I have £24 to play with. I'm not so sure. It's a big risk. So I'm just going to go with maybe 3. Playing it safe. Oh, it's lower. In which case, it was lower. And if I had have put a lot of my points, I would have lost them. So in this case, I've only lost 3. Now, because this one is an ace, is there any cards lower than an ace? No. That means I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 out of the next 9 out of 9, that it's going to be higher. There's no other aces, there's nothing lower, so that means 9 out of 9 chances of it being higher is 100%, it's certain, it will happen. In which case, I'm going to say higher. And I'm saying 9 out of 9. Okay, yes. I have 21 points or pounds. How much am I going to risk? I'm going to risk the whole lot because it's a certainty. It's going to happen. So I'll put 21. Play. And it is. And again, because it's sort of a lower card, I've got a pretty good chance of it being higher than this because the cards that are lower than 4 that are left are 2 and 3. So it's got a good chance of it being higher. So I'm going to go higher again. And now let's have a look, do some calculations. 2 and a 3. 4 is gone. So I've got 5. 1, 2, 3, 4, 5, 6. I've got 6 chances out of 8. If I simplify that, 4/5. So let's put 4/5. No, that's a lie. What did I say? I've forgotten. 6/8, which is 3/4. 75% chance. I'll give it a try. Check. 3/4. It's a good chance that it's going to be higher. It's not certain. I've got 42. I'm going to risk 40. I'm feeling a bit risky. I'm going to give it a go. So I don't want a 2 or a 3. And if I don't, I've done well. It's a 10. Yes, I'm looking good. Okay, so this is what you want to do. You want to play the odds. You want to be clever about things. You keep track of it. And it's a good game. It helps you with your maths. What are the chances of you succeeding? I'd say pretty highly. The more you play, the more you play. A bit like the more you know, the more you know.